Hi, welcome back. In this session, we are going to talk about the scan techniques. So, in these scan techniques, the dozens of command line flags or switches are available to make the system more powerful and flexible. So, in this session, we try to cover only options that relate to port scans and often describes only the port scanning related functionality of those options. So the selecting a scan technique is what type of scan you are going to performing and which command line flags or switches are going to be used. So one of the first consideration when contemplating a port scan is deciding what technique to use. So Nmap offers about dozens much methods, and in this session we provide a brief summary of them. And only one scan method may be used at a time, except that UDP scan may be combined with any one of the TCP scan types. So, as a memory aid, port scan type options are of the form, it starts with minus S and followed by a capital character, where a capital character is a prominent character in the scan name, usually the first. So if it is TCP scan, then T. If it is UDP scan, then we use U. Okay. So the one exception to this is the depreciated FTP bonus scan will be there. That is minus B we use. We talk about that. So by default, Nmap performs a sign scan, though it is substitutes a connect scan if the user does not have proper privileges to send raw packets that requires the root access on Unix. So the port scanning methods supported by the Nmap one is your fully connected, that is TCP connected scan, that is fully connected we say. So it connect this connector scan use the system call of the same name to scan machines, so rather than relying on raw packets as most of the other methods do. So it is usually used by unprivileged Unix users again and against IPv6 targets, because sign scan does not work in those cases. Another type of technique of your scanning technique is TCP sign scan. So with your TCP connect scan is a fully connect scan, we said that the connection is going to be established in that. So it all the three handshaking process completes in TCP connect scan, whereas your TCP sign scan known as a half scan, that means the connection never establishes it. So this is far and away the most popular scan type, because it the fastest way to scan ports of the most popular protocol TCP. So it is stealthier than connect scan, and it works against all functional TCP stacks, unlike some special purpose scans such as your FinScan and that. So another one is your FinScan. So in the FinScan, this special purpose scan type are adapted at sneaking past firewalls to explore the systems behind them. So it used the switch minus S capital F, where F gives the finishing scan, where capital S gives the sign scan information. So another one is Christmas tree scan. So this Christmas tree scan is also a special purpose scan type, which is adapted to again the sneaking the past firewalls to explore. As well as another one is null scan, which use the switch minus SN, and it use the ping scan, that is pinging the targets. It use the minus S minus P. and it used the UDP scan, that minus S capital U, the UDP scan. So this UDP scan, that don't forget this UDP ports, they just offer plenty of security holes too. And another one is you find acknowledgement scanner ACK scan. So this ACK scan is commonly used to map out firewall rule set. So in particular, it helps understand whether firewall rules are stateful or not. So the downside is that it cannot distinguish open from closed ports. Another one is, you find other type of scans like the TCP window scan. So where window scan is like acknowledgement scan only, the ACK scan, except that it is able to detect open versus closed ports against certain machines. And you will have the TCP Maimon scan and TCP idle scan, TCP protocol scan. I'm not going to discuss much about them here. So these are different types of scans techniques are going to be used. So let us observe the first scan, that is the TCP connect scan, how it performs. So as we know that your Nmap can run in two different ways for scanning the services on the target machine, whether it is a TCP scan service or UDP scan service. So these services use this for scanning these services on TCP protocol, TCP Connect scan or Sign scan or ACK scan or Fin scan. So far, whatever we discussed will be used for scanning the services or the ports, whether they are working, they are active or deactive on the target system. For that, UDP scan will be used. So in this session, we focus on the TCP scan. So in the TCP scan, as you know that to get the details, the Nmap TCP Connect scan works in two different ways: privileged user scan and unprivileged user scan, to find out whether the services are, active or not. So in privileged one, it uses the sudo, which gives the administrative privileges to run the nmap, which brings the raw packets. So for example, by giving nmap, which is following after your sudo, and giving the switch like minus s minus u. So for UDP, by running the UDP scan, it requires the administrative privileges. Whereas the non-privileged users, that means without your sudo, this is basically used to scan the TCP connect port scanning. So it simply use minus S capital T. So there, the Nmap uses the system calls to connect with the target, whereas in privileged users, when it runs, it provides the raw packets, means it is more powerful than the the Nmap non-privileged one. It just gives only the limited information compared to your privileged user information. So now let us see how the TCP Connect scan works. So in the when pen testers trying to scan the ports on the target machine, by using the TCP Connect scan, your Nmap, when try to scan whether these to find out the response of these ports, their status of these ports, Nmap request the operating system, because Nmap runs the TCP Connect scan runs under the non-privileged user mode. So Nmap requests the operating system to connect to the target on these particular port numbers, port number 1, 2, 3, up to 65,535. So any port number which you can specify. Okay, so then the operating system will issues a connect call, system call. That connect call will have the target IP address and the port number which is requested by the Nmap, and that is given as a request to the target. If the target is based open this particular request and analyze that data or payload inside the packet and check whether it is able to run give the connection or not. So it gives the response. So in TCP Connect, how it works, the target pen tester send the sign request, that is the IP address and the port number will be there in that sign request. And if the port 22 suppose requested by your pen tester, if it is open, and if your target machine is ready to connect with the PN test, then it gives the acknowledgement for this requested sign request, and also showing its willingness to communicate with the pen test. So it sends a sign request. And when pen testers trying to gives the acknowledgement for this sign ACK response, and along with this acknowledgement for this sign ACK, pen testers also issues the or sends the reset packet to the target. So this reset packet or the reset flag bit enabled packet indicates to the target that I don't need to establish a connection. So in this case, just pen tester is trying to check it out by the first three steps, that whether the port is open or not, but not sending uh, port is open or not. So here, by using three handshaking method of your TCP three handshaking connection establishment, the connection is fully established here. And once connection is established, immediately informing the target that just ignore all the previous packets. I don't want the connection anymore. I don't want to send any data for this open port. Another one is if the pen testers send a sign request and for connecting with the target, and if the ports which are requested by pen tester, if that port number, suppose for example, port number 39 is requested by pen tester, and if that is closed, suppose, or the application which is running on this particular port uh, uh, is not responding, suppose, or inactive, suppose, then it sends the reset packet because the port is closed. So by receiving this reset packet by operating system here, that operating system gives it back to Nmap. Nmap understands that the port is closed. The port is closed. And the third way is when pen testers issues, if the network is configured with any firewalls or intrusion detection or intrusion prevention system on the target side, and when pen tester trying to scan the ports whether to check their status, when it sends the sign request, then based on these firewalls and IDS and IPS, they are basically, if the rules are not matched, all those packets will be dropped, will not be allowed inside the network. Means those packets cannot reach to the target system. Right? They simply drop. That means there is a restriction here. So the for in this case, your pen tester is trying to send the same sign request packet again and again. Means retransmission is taking place, but for as times goes on, it is not getting any response. It is not getting any response. So then your pen tester, the nmap on your pen tester assumes that on the target side, there may be the firewalls or IDS or IPS are configured. So the ports are filtered. In the same way, the firewalls will not allow any acknowledgements or any packets from your inside network to the outside the network. So all those packets are also bound. So generally, if the system administrator on target side configured that only the internal users can use, means communicate with each other through the specified port number 8080, suppose, then only they can use. And if any target system wants to communicate with any target systems which are outside the network, so they're outbound, is completely disabled here, so the packets will be dropped here. So the first scan is called your TCP connect scan, as we discussed. So in this case, what is happening? Nmap attempts to complete the three-way handshake on each ports, like right from port number 1 to your 65,535 ports. So this scan is actually completes the three-way handshaking and then tears down the connection gracefully. So there is a little chance that you will flood the target system and cause it crash, right? So if you do not specify a specific port range, then nmap will scan the 1,000 most common ports, as we discussed. So it is always recommended to scan all ports, not just the 1,000 common ports, right? So now we'll see this practically, and we'll try to analyze these responses of the packets. Let me share the screen with Kali. Okay. Yeah. So let us first check how the TCP Connect works. So in this, let us get into the discussion here that let me quickly go to. Yeah. So in the TCP scan, as we said, TCP Connect scan is the default TCP scan type, right? So when sign scan is not an option, then this is the case where a user does not have a raw packet privilege or is scanning, suppose IPv6 networks like that. So how it does that? In this, let us see the example by scanning this. That by just issuing the command that nmap, sorry, here is just TCP file use. Okay, so here let me give the command that nmap and use this switch. I'm just going for the scanning with the TCP scan. By default it scans the sign scan, but go with the TCP scan. Okay, by giving this TCP scan command, and which is followed by, suppose I don't want to go with uh, the scan discovery, I mean host discovery. So let me just give the minus p, sorry, minus capital PN. So skip the host discovery process and scan the ports. Suppose port number 22, by giving the distributed port scanning, port number 22 139 comma suppose 888 port number, and the target is suppose 45.33.32.156, and just run this, uh, and along with that let me just scan these packets on the Wireshark. So and here let me just filter the IP of this particular address and give the to capture the packet. So let me just run the command here again for these ports. Okay, so here your TCP is, I mean the we'll see this by issuing this command. We find here that there are two ports which are sorry, this 22 port is using the TCP service. So we have done the TCP scan here. So TCP scan, and it is saying that this port is open and it provides the service SSH. Another port is 139, which we have issued. This port is also the TCP service port, and which is filtered, and the service is the network basic input output system. Another port is closed. So we find here three different responses for the three different ports. So let us quickly analyze it in the Wireshark, how it is. Let us see. So the first here in the Wireshark, you can see the sequence numbers are given here, and the time, at what time the packets are transmitted, the source IP address, that is my Kali Linux IP address, and the destination IP address is the scanme.nmap.org destination IP address, which we have given the destination IP addresses, and the source the protocol which is using, and at the last field it is giving the information about the packet. So let me just maximize it. Oof. Okay, so here you can see that the details here, if you go into this source packet, so first it is running at the 26th sequence number. You can see the sender is Kali Linux, destination is 45.33.32.156 using the TCP packet, and requesting for the 139 port number to check whether the port is open or not by sending the sign request packet. So it is maintaining the sequence number, and the that is sequence number is 0, and our machine is trying to scan the port number status of your 8080. So it sent that the source machine is ours and destination is 45 the dot 156, and for that the request is sent this sign request, the sequence number 0, and another port number is 22. The sign request is sent to it. Now, three requests are sent from your source to destination here, right? So from here, you can just see the details that the from for all these port numbers. Let me just run the command again. Just check it out. Okay, and go to the TCP scan. Yeah. So here you can find now the details. So the request is sent here for port number 22, and the retransmission is done for port number 22, port number 139, port number uh, I mean 22 again. Okay, so here at this point you can see here we got a response. We got a response from the target, that 45.33.32.156, and destination is our system. So we got a response for this, that in that response you see that there is a acknowledgement for this particular request. So that is a 6 521 for this request. You got a reply. In that reply, acknowledgement is there. This acknowledgement is the acknowledgement for this sign request, and sending that RST as a reply. RST means what? I'm not ready to communicate with the source. So here you can see for this particular 8080, if you go to the Linux, it is given that 8080 is closed. That means the port is closed, so not ready to communicate. Not ready to establish a connection. So we got another reply from the target, that 22, and for a request 56856. So we got a reply for this. In that reply, you find the acknowledgement. Along with acknowledgement, you're having the sign request again from the target. That means what? Your port number, the target machine is ready to establish a connection with the source. That means the port is open. So for 22, if you look at that, it is given that 22 port number is open and it is providing a service SSH and ready to communicate it. So then you can see here that for the uh, uh, so the connection can be established here, and you can observe that at this point 56850 it is providing a acknowledgement. So when for this particular response providing the acknowledgement, that yes, we can establish a connection. So three handshaking process completes here. So in TCP connect, the all the three steps are successfully executed. So the connection is successfully established between your pen tester and the target machine. And immediately after that, your pen tester is sending a reset request, a reset packet, along with the acknowledgement for this sequence, acknowledgement for this acknowledgement packet. So what it means, it is simply saying that for this acknowledgement one, the acknowledgement one, it is sending the reset packet. So what it means, it is simply saying that I don't want to transfer any data, ignore all the previous packets, and I don't need to continue the connection, right? So now you can see that for 139 connection, for the connection 130, for the port 139, the source is continuously sending a packet sign request here, and you can see the sign request here. Another means retransmission, another packet is transmitted, and there is a sign request here, another packet is transmitted here, and there is a sign request here. So what it means, the packet, the TCP packet is going and the sign request is retransmitting, but there is no response from the target side. That means your nmap assumes that the on target side, whether firewalls or intrusion detection system or intrusion prevention systems are configured on the target side. So that's why it gives the response as the 139 port is filtered. They are continuously dropping the packet. They're continuously dropping the packet. So this is the that you can analyze here how the packets are running here, right? So now let us see the difference between the UDP and the what you call we can see the difference of your scan map. But with this, I just like to stop. We'll talk more about this TCP connection. So here, instead of giving the IP address for a single, so you may try to scan the range of systems also. Like you can give another target name, that 45 dot uh, 45 dot 33 dot 32 dot, suppose another system like 190, if it is active or not. If it is active, then it start going and scanning them. So for multiple ports also, it gives on these ports, you find all are filtered, means all the ports are filtered on this particular target machine. So let us see the TCP packets for the other IP addresses. Let us see these. Let me just scan this with the filter this with this IP address. For 90, let us analyze for 90. Here you can see that the source is, no, here, from here you can see that The source is our target machine and sending a IC, sending a request for the particular port, whether it is open or not. That is 139 for port 22, and for port your 880. So your funding, you can see here, there is no reply came from these ports. So here it is saying that instead of giving this result, you can find in the ICMP got some response that the destination is unreachable. So in destination is unreachable means the host administratively prohibited. So you are not getting any response from them. That means what? All the ports, port number 139, port number 122, or port number 880, okay, all these ports are blocked. Or you can also, once again we'll try to run this for these ports, and let us observe in the TCP. So now here you can see this by running this port number again. So we are not getting any response from them. So then Nmap understands, or Nmap says that these ports on this particular machine, on this 190 machine, all these ports are blocked. So what is the drawback of these the TCP connect means it takes a longer time to scan all the ports. Suppose instead of scanning only these ports for a single system, if we give the for a single target, if we instead of giving the distributed port scanning, if try to scan all the ports, and observe that it takes much time. So that means all the ports. That means the most here by giving minus p minus means all the 65,535 ports are going to be scanned. So for every port scanning, it is going to means the source and destination both are going to exchange 4 packets. So then assume that 65,535 ports are going to be scanned, and it finds the open ports are 22, and your 80, 9929, 3133 are open, all the remaining are closed. So 65,495 ports are closed, TCP ports are closed. So that connection is confused here. And out of that, 35 ports are filtered TCP ports. That is, there is no response. There is no response from the target side. Right? So here the mean is it is going to take for scanning all ports, it takes long time, as we observe, nearly 21.57 seconds are there, and it is going to establish a fully connection over there. So then the log will be recorded on the target. So if on target side, if intrusion detection and intrusion prevention can detect this scan, so it needs the more packets. So that is the major drawback of this particular let me just share the screen. Yeah, so here you can see that there are more packets are going to be transmitted. So there is a retransmission is takes place here continuously. So in that case, more packets are going to be exchanged. So that is the only major drawback for these different port numbers. That is the major drawback of the TCP connect scan, because for every port you need to send 3 packets for connection establishment and 1 packet for resetting the connection. So that is the drawback of your TCP scan. So to reduce the number of packets for port scanning, you can go with the default scan, that is your sign scan, that we will discuss in the next session.